Welcome to video lecture on heat transfer. Myself Khushbu Shah, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. In our previous session, we have completed the types of evaporator which comes under the natural circulation evaporator types. Right, in that we have seen all the 4 types of evaporator: open pan evaporator, horizontal tube evaporator, short tube vertical evaporator and falling film evaporator. Now in today's session we are going to see another type of evaporator, which is the forced circulation evaporator. Right. Let's see what is the basic difference. In natural circulation evaporator, the liquid enters the tube at a velocity of 0.3 to 1 meter per second. Understand this point, it is very important. Right. In natural circulation evaporators, the liquid which enter the tubes at a velocity of 0.3 to 1 meter per second. While in forced circulation evaporator, the liquid velocity is of the order of 2 to 6 meter per second. So you can see the difference between the velocity of the liquid. In natural circulation, it is 0.3 to 1 meter per second. While in the forced circulation, it is 2 to 6 meter per second. So it is a large difference between the velocity of the liquid. Right. In forced circulation evaporator, there are 2 types. Forced circulation evaporators with horizontal external heating element and forced circulation evaporators with vertical external heating element. There are 2 types under forced circulation evaporator. The basic method or the basic principle for this forced circulation evaporator for these 2 types is same. Just the difference between these 2 is, as you can see in the name, first is with horizontal external heating element and second with the vertical external heating element. But the basic method of working of that in both the evaporator is same. Let's see. See, this first figure shows the forced circulation evaporator with horizontal external heating element. This external word is very important. See here, this is the evaporator body and this is the heating element. If you remember, in natural circulation evaporator, this heating element is always inside the evaporator body. Right? While in this forced circulation evaporator, the heating element is outside the evaporator body, external. That's why I am saying that this external word is very important. Right? So, this is the first type with horizontal external heating element. See, in the figure, this is the evaporator body where this deflector is provided. You know what is the basic function of deflector, as we have discussed in falling film evaporator. Right? The feed which is to be concentrated is introduced from here. It is transferred to the heating element with the help of this pump. In horizontal external heating element, in the majority of the cases, we are using 1-2 shell and tube heat exchanger as a heating element. See here, we have written 1-2 shell and tube heat exchanger. Right. So this is the horizontal and the position of this 1-2 shell and tube heat exchanger is horizontal. Right. In this, the steam is introduced from here and the condensate is taken from this outlet. And the feed is coming from this with the help of pump to this heating element. And evaporation takes place. In this heating element, the vaporization starts and the mixture of vapor and liquid goes through this pipe to this evaporator body. Right? So, in these forced circulation evaporators, by increasing the velocity of liquid flow through the tubes, net heat transfer coefficient increases enormously and it also prevents the scale formation of heating surface. As we discussed, in forced circulation evaporation, the velocity of liquid ranges from 2 to 6 meter per second. It is high compared to natural circulation evaporator. What is the advantage of this high velocity? of liquid. Due to this high velocity of the liquid, the heat transfer coefficient increases. And also it prevents the scale formation on heating surfaces. As the velocity of liquid is high, that means it passed with the high velocity, the scale formation chances are very less. So these are the two advantages of using forced circulation evaporator. It provides high heat transfer coefficient and it prevents the scale formation on heating surfaces. Right? Let's see the figure of the second type. See here. This is the forced circulation evaporator with vertical external heating element. And the remaining things you can see in the figure, if you compare the previous figure and this one, the parts of this evaporator are same. Which are the parts? It consists of this circulating pump, separator, evaporator body with vapor outlet at top, deflector plate, and outlet for discharge of the thick liquid, and external heating surface element. Either it is horizontal or vertical. These are the main parts of forced circulation evaporator. Circulating pump, separator, evaporator body with vapor outlet and thick liquid outlet, deflector plate and external heating element. Either it is horizontal or vertical. In this second figure, you can see this heating element is in vertical position and it is outside the evaporator body. That's why it is known as the forced circulation evaporator with vertical external heating element. In this, as we are using pump which is of a centrifugal pump type, this centrifugal pump forces the liquid through the tubes at high velocity and is heated as it passes through the tubes. Right, so here the feed which is to be concentrated is passed through the tubes and steam surrounds the tube. So function of pump is to force the liquid through the tubes at high velocity and it is heated as it passes through the tubes due to heat transfer from condensing steam on shell side. So the feed to be concentrated is inside the tube and steam is outside the tube. And heat transfer takes place between that two. Boiling does not take place in the tubes. Solution becomes superheated and flashes into the mixture of vapor and liquid just before entering the separator. Right? And the two-phase mixture, which is vapor and some unvaporized liquid, that impinges on a deflector plate in a separating space. We are providing deflector in evaporator body top. So the two-phase mixture from the heating element impinges on a deflector and the vapor is removed from the top and liquid is returned to the centrifugal pump where the makeup feed is introduced. So the part of liquid leaving the separator is withdrawn as a concentrated liquid and the makeup feed continuously introduced at pump inlet. Right? In case of vertical heating element, single pass silent tube heat exchanger is used. If you remember in horizontal heating element, we have mentioned 1-2 silent tube heat exchanger. While in vertical tube heating element, we are using single pass silent tube heat exchanger. Right? So this is about the forced circulation evaporator with external horizontal heating element and external vertical heating element. Now let's discuss about some of the advantages and disadvantages of using forced circulation evaporators. First, discuss advantages. The advantages of using these forced circulation evaporator is it gives high heat transfer coefficient, even with viscous material also. While these natural circulation evaporator we are not using in majority of the cases for viscous material, because what is the main reason behind it? That in the natural circulation evaporation, the velocity of the liquid is less. While in the forced circulation evaporation, the velocity is high, and for viscous material, we require high velocity. So the first and most important advantage of using forced circulation evaporator is it gives high heat transfer coefficient even with viscous material. Close control of flow. Close control of flow is possible only in forced circulation evaporation. Another advantage is due to high velocity it prevents the formation of deposits on heating surface, as we have discussed. In natural circulation evaporation, deposition of scale formation chances are more compared to natural circulation evaporation, because in natural forced circulation evaporation velocity of the liquid is high. That's why due to high velocity it prevents the formation of deposits on heating surfaces. Another advantage is heat sensitive liquids can be handled with forced circulation evaporation. Heat sensitive liquids cannot be handled in natural circulation evaporation. Let's discuss some of the disadvantages. The major and most important disadvantages of using forced circulation is high pumping cost. As we discussed, in forced circulation evaporation, we require high velocity of liquid. And if you remember the figure or the types of natural circulation evaporation, in none of the type we are using pump for transferring liquid because the velocity is low. And if we want the liquid to flow at high velocity, we require some pressure element, some element which supply pressure to that liquid. And that's why we are using the centrifugal pump in case of forced circulation evaporation. And that's why the pumping cost is high in case of forced circulation evaporation. Right? So the most important disadvantage of using the forced circulation evaporation is of high pumping cost. Right? So in today's session we have covered the another type of evaporator, which is the forced circulation evaporator. In that we have seen both the types, forced circulation evaporation with external horizontal heating element and forced circulation evaporation with external vertical heating element, both construction and working, and we have seen the advantages and disadvantages of forced circulation evaporation. So till now we have covered all the types of evaporators, natural circulation and forced circulation. Right? So I am completing my session here. I hope this session is clear to all. Thank you.